Sir, you can proceed now. Around 55 participants have joined. They will join later, sir. Am I audible to you, sir?
Yes, sir. Yes, sir. Just 1 minute. I'm just.
You can start your video,
back.
sir.
Yeah. Am I visible?
Yes, yes, you are visible, sir. You can proceed.
Okay, so now I'm going to start.
Okay, sir.
And the agenda for today is the t-test and the Anova test. So where we can apply t-test and where we can apply Anova test. Okay, so I hope I am visible. You can see me.
Yes, yes, sir. You are visible. You are visible to all.
Okay, great. So let me start. So first, I will explain the basic concepts of the t-test and the Anova test, and then I will start. So in the statistics, there is an area, and this area is known as test of difference. This area is known as test of difference. And what we are doing in this test of difference, we are comparing different groups. Like for example, this is case number 1. When you want to compare a population mean, this is a population mean, and we are assuming that it is equal to the sample mean x bar. So in this case, we are comparing the population mean and the sample mean. And this example is known as, this case is known as one sample test. One sample test. In second case, we compare two different means. Mean of sample 1, and we assume that it is equal to the mean of sample 2. This is known as independent sample test. Independent sample test. So this is the case number 2. In case number 3, we are having the same sample mean, then some event happens in between, and after we measure the sample mean again. So this mean is known as pre-mean, and this mean is known as post-mean. So this is simply known as paired sample test. And the fourth case that we will do today is when there are more than 3 or more than 3 groups. When we are having 3 and more than 3 groups, like mean 1, mean of group 2, mean of group 3, mean of group 4. So when you compare the mean of more than 2 groups, this is called one-way Anova. So these are the 4 tests that we are going to discuss today. Okay. Now let me tell you one thing. In all the cases, what we are comparing? We are comparing the mean. Population with mean with the sample mean, and sample 1 mean with the help of sample 2 mean, and sample pre mean with the post mean, and the mean of the different groups, right? So this is the case which we are going to do. Okay, so let me open one Word file so that I can transfer these notes to you. So let me if you need, I will transfer all the notes to you so that I can make a Word file and will paste the examples here. Okay. Now I'm going to the case by case. First, we will discuss case number 1, give some examples to you, then explain case number 2, then give examples to you. Similarly, we will do the 4 cases today. Okay, now let's move to the case number 1. The case number 1, I said, is the one sample test. One sample test. So one thing I want to tell you is, there are actually, we are discussing the population here, and there are 2 cases we have in the research when the population is known, when the population is known, and second case is the population is unknown, population is infinite. Now if I ask you that, do you have the data of the people who are using the mobile phones, or if I ask you that, do you have the data who are using the laptops, or if I ask you that, do you have the data that the customer who are using the car, your answer will be no. We don't have the data of these customers, right? Because they are infinite. Similarly, if I ask you, do you know the faculties in your campus? You say yes. If I ask you, do you know the research scholars or PhD students or MBA students in the university? You say yes. If I ask a manager that, do you have the data of your employees who are working with the company? He say yes. So you can understand that there are 2 types of population. When the population is known, like a university, within a campus, within a company, within a premises. So in that case, population is known. But in different cases, in 99% of the cases, I'm telling you, in 99% cases of the results, the population is infinite, and we don't have the data of the population. So now, because of that, we have here, we have the data of population. So I write here population, mean, and variance. If the population is finite, if the population is known, you can calculate the population mean and variance. But if the population is infinite, you do not have the population mean and variance. So this is the issue that we have in the research. Now, why I am telling you these 2 differences? Because if you have this case, you can apply Z-test in comparing the mean, and otherwise you have to apply T-test in comparing the mean. So I hope you understand what I'm saying. Why Z-test is not practically possible and why t-test is so popular. So here you know that in statistics, in books, the Z-test is very common, because in books you can create the data and give the examples and to solve the numericals. But when you go to the practical research, most of the time you found that my population is infinite and I do not have the data of population mean and variance. So 99% of the cases you have to apply t-test. And that's why most of the softwares like SPSS and many other softwares, they don't have the Z-test. They only have the t-test. Right. So we will focus more on the t-test, and because Z-test is not applicable in the research, so we are not going to discuss the Z-test, because it is only an imaginary concept that population is known and the population mean and variance is known. It is just a imaginary concept. In research, it is not applicable. So we have to apply only the t-test. And most of the softwares don't even have the Z-test, because they know that you are not going to apply Z-test anytime. You have to apply only the t-test, right? So we are going to focus only on the t-test. Okay. Let's move to the first test, that is called one sample test. I think this concept is clear. Let's move to the one sample test. And because we are going to apply the t-test, so I will call it one sample t-test. Right. So in this case, we are having a population mean represented by mu, and we will compare it with the sample mean, that is called x bar, and we have the null hypothesis that the population mean is equal to x bar. Okay. Now I'm giving you many examples to understand that where we can apply t-test. Okay. Example number 1. You know that Maruti cars, right? So there is a car called Maruti Celerio, and they claim that the average mileage of the car is 25 kilometers per liter. So this is the average mileage of the car. Similarly, you know that there is a company VLCC, and this company claims that if you join the company, the average loss in the weight is 5 kg in a month. Similarly, there is a Hero Honda bike and they have a Splinter bike, a Splinter. Okay, they say that the mileage of the bike is 85 kilometer per liter. Similarly, there may be any college, MBA college, and this MBA college say that the average package of the students is 7 lakhs per annum, right? So in this case, in all the cases, you know that there is a claim. This is a claim. Claim means the company is making a statement about their product, right? Like the average mileage of the car, the average weight loss, the average mileage of the bike, the MBA student. So we came across about these averages very frequently. Most of the people, they claim about their performance. Now what we are doing, and all the values are basically the mu. All these values are representing what population mean, because why it is a population mean? Why? Because it is about all the products, each and every product made by the company. And to examine the truthness of the statement, we take a small sample and calculate the mean of the small sample, and we'll check whether they are saying right or not. So for that, we apply the t-test, and here the formula is simply the mu minus mean upon standard error, which is sigma square upon n minus 1. So this is the formula for a t-test, and we are examining the null hypothesis that the population mean is equal to sample mean, and this is examined with the help of two methods. One, we compare the value of t that should be greater than 1.96, and we also check the probability value that should be less than 0.05. So in both the cases, in both of these cases, you reject the null hypothesis. In both of these cases, you reject the null hypothesis, right? So this is about the one sample t-test. So now I'm going to show you some examples in SPSS that how we can perform one sample t-test. Okay. So whatever I am teaching you, I am pasting in a Word file so that I can share with you all the notes. So I hope you can see the notes. Yeah, so this is, I'm making a Word file to share these notes with you. So now I'm going to open a file, SPSS. I'm showing you how to do one sample t-test in the SPSS. And in SPSS, what we are going to do, we are just going to compare the population mean with the sample mean. So I will have show you some examples. So let me open the SPSS file, and now I'm going to open the data. I already keep all this data in my Facebook page, so you can download from there. So this is the t-test, and we are going to apply one sample t-test. Open. Okay. So in this example, suppose the VLCC, this is the example of VLCC. Suppose the company say that if you join our company, we will lose your weight by 5 kg in a month. Right. So this is the claim. So here population, what is the population mean? Right. So let me write here. So in this example, the company claims that if you join the weight loss program, the average reduction in weight, average weight reduce is 5 kg. So one thing we can draw from here, that my population mean is equal to 5 kg. So because I am not convinced with this 5 kg, so I take the data of 50 customers. And calculate the sample mean. Right. So this is the data of 50 customers. You can see this is the data. And from this data, I am going to apply one sample t-test to check the null hypothesis whether my sample mean is equal to 5 kg or not. Right. So this is the meaning of one sample t-test. Now let me show you that how we can do it. This is the data set. You go to analyze, go to compare means, and here the second option is one sample t-test. So this is the command of one sample t-test, and let me run this. So the software is asking me where is the sample data and where is the population mean. The test value is nothing, it is a population mean. So my population mean is 5 kg. So I will put 5 here and my sample data is here. So this is my sample data. Now I am going to run it. So two things you have to do here. Okay. Now how to interpret the result. Now I am showing you how we can interpret the results here. And both the tests you can see here. In this case, as you know that my population mean is 5 kg. So population mean you can see here. Now what is the sample mean? Sample mean is found to be 4.02 kg. So actual weight loss by is for 4.202 kg of the sample. Now I am going to check two things. One is what is my t value, what is my p value. The t value is found to be, where is t value? This is the t value. T value is found to be minus 6.212. And what is my probability value? Probability value is this 0.00. So what is the conclusion? What is the conclusion here? Conclusion is that because T statistic is more than 1.96 and P value is less than 0.05, so null hypothesis can be rejected. Null hypothesis can be rejected, right? It means company is making wrong statement. So this example is the example of one sample t-test. So I just repeat this example just to confirm the learning, and let me do it once again, and first clear it, and we do not want to save it. This is my data. I'm just repeating the command. Go to analyze, compare mean, one sample t-test, and in population mean it is 5, and the sample will go here, and you just click OK, and you will see the results. This is the population mean, this is the sample mean, and a t statistic and p value. So these four things we have to check in this example. Okay, now I'm moving to the second example, second case, which is called independent sample t-test. Now my second case is independent sample t-test. This is the most popular test we have seen in the research, so I will give more time to it. In independent sample t-test, we have the two means. Mean of the group 1, this is group 1 or sample 1 you can say, and this is the mean of the group 2. So this is the group 2. So some examples I am giving to you so that you can understand. Sometimes we compare the performance, like can we say the performance of public and private banks are equal? Performance of private banks. So here public banks is group 1 and private banks is group number 2. And number 2, right? Salary of male employees and female employees. So here male and female are two groups, and we can say we want to compare the average salary of male and average salary of female, right? Similarly, students compare the can we say the average publication of assistant professor and associate professor. So here we are comparing the two groups, right? Similarly, for there are so many examples, and sometimes we also compare the junior managers and versus senior managers. So in all the cases, in all the examples, we have one thing in common. What is the common? Number one, there are two groups, and one more thing, there is a scale variable. If you see all the things clearly, in all the examples, there is a scale variable. What is the scale variable? Like performance, salary, publication, right? And here we must have some examples. So one scale variable that should be compared between the two groups, and there are two groups like public and private, male and female, assistant professor, associate professor, junior manager, senior manager. So we are having two groups to compare, right? So I hope you understand this, and let me copy this first. Okay. Now let's move further. So what we are going to do in this case, number one, we make the null hypothesis that the mean of sample 1 is equal to the mean of sample 2. This is the step number 1. In step number 2, we will check whether these two samples can be compared or not. So can we say whether two samples have equal variance or not? Whether two samples have equal variance or not. First of all, we have to check this assumption. For this, the F statistic should be greater than 4 or 3.9 something, and probability value should be less than 0.05. So this is the case we will check to see whether these two samples have the equal variance or not. So there are two possibilities. We can say yes, their variances are equal, or their variances are not equal, right? So then we if variance is equal, then we check the upper value of t, upper t and the lower t. So I will explain you what is the upper t and lower t. And in both the cases, the concept is same. The t value is compared with respect to 1.96, and p value is compared with the help with 0.05. Same here. So when I show you some examples, you can compare what I am showing you. So this is the simple procedure of the independent sample t-test. So let me show you the independent sample t-test first with the help of some example, so that we can understand this. Now I'm opening the file for independent sample t-test. This is the example number 2. Like this is the example of independent sample t-test. So in this case, first of all, let me explain the data with you. In a company, there are two departments. Let me share the data with you. Yeah, I hope you can see the file. And suppose in a company, there are two departments. One is called audit department and one is called sales department. And the property of both the departments is that they go to the outside and present their travel expenses. So here the null hypothesis is that the travel expenses of audit department is equal to the average, sorry, average भी आएगा, average travel expenses of the account department, of the sales department. So this is the null hypothesis, that can we say the average travel expenses of the audit department is equal to the average expenses of the sales department. Now we are going to apply the independent sample t-test. You can see this is the data, and if this is the groups. If I click on this button, you can see that we are having 9 observations for the sales department and 9 observations for the audit department. Okay, so let's apply independent sample t-test. Now I am going to analyze compare means, and I am selecting the independent sample t-test option. So here travel expenses go to the test variable, and group will go to the group variable, and I am defining the groups because I define the groups with the number 1 and 2. So I am typing here 1 and 2, 1 and 2. So we are having 1 and 2 here, travel expenses here. So command is complete. Let's click OK. Now, if you remember, I told you 2 things. First of all, we have to compare the F statistic. So this is my F statistic, and this is my p value. So the step number 1. So let me explain you this thing. Step number 1, check F and its p value. So here F statistic is 0.851 and p value is this 0.370. What it means? The null hypothesis accepted. It means what is, if null hypothesis accepted means the variance of the 2 samples are equal. The variance of the 2 samples are equal, and this test is known as Levin test for equality of variance. So we first check this Levin test for equality of variance. Then step number 2 comes. In step number 2, we will check the t-test for equality of means. So now what we have to check here, I explain you that if we are accepted the hypothesis, we have to check the upper value of t. So this is known as upper t, and this is known as lower t. So this is known as upper t, and this is known as lower t. So we have to check the upper t here because null hypothesis is accepted. So what is the t statistic? T statistic is 4.123 and probability value is 0.001. So this is your probability value. So now you know that if t value is more than 1.96 and p value is less than 0.05, the null hypothesis that the group means are equal rejected. So we reject the hypothesis that the travel expenses of the 2 groups are equal. Null hypothesis rejected, and then we have to check the mean. So which mean is high? Sales department mean is high. So we can say the average travel expense of the sales department is significantly higher than the average travel expenses of the audit department. So this is the conclusion. So we conclude that the average travel expenses of the sales department is significantly higher than the average travel expenses of the audit department. So I hope now you understand what is the independent sample t-test. Okay. Now just type in the chat box whether you are getting my sessions or not. Are you understanding or not? If yes, type yes. Otherwise, I will go to one more example of independent sample t-test. Okay. So you are understanding? Okay. So I will explain. I will take one more example so that you can understand clearly. And this t-test is quite important because this is frequently applicable test. We applied this test quite frequently. So I am going to the second example. Let me open the file. Okay. So this is one of the example that I can show. In this case, we are having the data of the gender. So you can see that we are having the male data and female data. So data of the male employees and the female employees. And the first variable means the first variable is that the number of years in the current job. So right, number of years the employee in the current company, right? So from how many years the employee is in the current company, and I want to know that which employee, male employee and female employee, which employee spent more years with the company, right? So I just write something here to explain you. My research question is that whether the male and female employee spent equal time in the company or not. So my null hypothesis is that the average time spent by male employees is equal to average time spent by the female employees. So this is my null hypothesis. So what I will do, I will check F test and T test. The F test will tell me this is just assumption. It is not a test. It is just assumption whether two groups are comparable or not. Whether the two groups are comparable or not. So here we examine the hypothesis that the mean of first group is equal to mean of second group with the help of t value and p value. So this example we are going to do just now, and so let's see. Let's clear it. Now you have the idea. This is my gender and job retention. So go to analyze, compare means, independent sample t-test, and what we want to compare this of, and I want to compare male and female, gender. So the software is asking that question mark. You can see these two question mark. Software is asking that what value you provided to the male and female, and you can see that they are provided. They are represented by 1 and 2. So let me write here 1 and 2. 1 means male and 2 means female. Continue and okay. Now how to check this? So first step number 1, I already explained you all the steps. So in step number 1, we have to check F value and P value. F value is here 0.001 and P value is 0.997. So we have to check upper value of T. Upper value of T is this. Second case, we have to check T statistic. T statistic is minus 2.25 and probability value is 0.029. Right? It means because whenever the T is irrespective of the sign and probability value is less than 0.05, then null hypothesis rejected. And right? So this is the conclusion. And I want to see one thing more. Male is spent. So male is spent 4 and 4.25 years in the company, and female is spent for 5.64 in the company. So my conclusion is that female employees spent more time with the company, spent more time with company, right? So this is the conclusion I can draw from here. So I think after this example, you have clarity on the t-test, independent sample t-test, and in this way, you can perform t-test very easily. Now, tell me, I hope it is clear now. Okay. So one more example I am telling you in this data odds itself. Suppose I want to see the average performance of the male employees and the female employees are same or not. Can I say the average performance of the male employee and female employee is same or not, right? So let me go to the one more example. Analyze, compare means, independent sample t-test, and we reset. I want to see the performance score here, and I want to compare the performance score on the gender. Gender I provided 1 and 2, and just click OK. So here the F value is again showing the null hypothesis accepted, means the two groups have the equal variances, and you can see the upper value of T. Now T statistic is less than 1.96 and probability value is less than more than 0.05. So here null hypothesis that the two groups have the equal means can be accepted. So now here we conclude that the mean of average performance of male and average performance of female are equal, because the p value is more than 0.05, right? So this is the third example of the independent sample t-test. Now let's move to the case number 3, which is known as the paired sample t-test. Okay, so let's come back to the whiteboard. This example is also very popular example in the experimental designs, very popular example. So this is known as paired sample t-test. So what happens in this case? You selected a sample, it is the sample, and you calculate the mean. So this mean is known as pre-mean. Then some event is happening, and after the event you again calculate the mean. This is called post mean, and the sample is same. Then you are comparing the pre-mean and the post-mean. So this is pre-mean and this is post-mean. You are comparing the pre-mean and the post-mean. This is the case of paired sample t-test. Now I am giving you some examples. Let's say you selected a class of 30 students and you take their test, that what is their average knowledge about the statistics. Then you teach statistics to the class, and after that you again take the test to check whether the average knowledge improves or not. Similarly, in a company, if you provide the training program to develop the skills, so you can measure the skill set before the exam and after the exam. In marketing, the marketing people take the data from the 100 shops. Let's say they take the data of 100 shops, and they calculate their average daily sales before the advertisement. After that, they announce some advertisement or the discount or some promotion schemes. And after that, after launching the promotion schemes, they want to check whether what is the new average daily sales of the shops. So if the daily sales improves after the advertisement, then they can say the average the advertisement is effective, otherwise advertisement is not effective. So in medical science, you know that suppose you measure the level of the patients, then you provide the medicine for depression, and after that you measure the depression of the patients. In this case, you want to see whether the medicine is effective in analyzing the impact of reducing depression or not. In most of the cases, you provide the medicine to the patient to check whether it is improving the patient or not. So this is the example of paired sample t-test, right? So just I repeat, you have a pre-sample mean and post-sample mean, and you compare pre-sample mean with the post-sample mean, and in all the examples you have to check the t-value and the p-value. So let me show you the example first, and there I will explain how we can run the paired sample t-test. Okay, so now let me go to the data set, and with the help of the data set I will explain you the results. Okay, delete these previous files, and we also delete this. Now I am going to open the data for paired sample t-test. Yeah, this is one of the example. Okay, now in this case, this is the data of a PhD program. This is just a simple data. So we are having the data of 20 people, and these are the basically villagers. So it is asked that what is your quality of life before joining the self-help groups, and now what is the quality of life after joining the self-help groups, right? So we are having two means here. Let me share the file with you. Okay, so here we are having the two different means. The first mean is the life quality before joining the self-help groups. So self-help group is a concept which is very popular in villages, and they provide the facilities, monetary facilities, livelihood for the women. So life quality before joining the self-help group, and after that the second mean is that life quality after joining the self-help groups. So we assume the null hypothesis. This is the null hypothesis that average life quality before is equal to average life quality after. So here before and after is very important thing. Now again we will compare this hypothesis with the help of t-value and probability value, and t-value we will compare with the help of plus minus 1.96, and p-value is compared with 0.05. So these two values will tell you whether to accept the hypothesis or whether to reject the hypothesis. So let me show the example to you. In this case, this is pre-mean and this is post-mean. So go to analyze, compare means, paired sample t-test. Now you can check. I am going to apply paired sample t-test. In this case, you have to make a pair of the two variables here and send here. Select both the variables, send here. Let me show you once again. Select the variables, select here. Okay. Now we are getting the data of getting the results of paired sample t-test. You can see that it is written here, paired sample test. So what we have to check, only two things we have to check here. What is the t statistic and what is the probability value? So t statistic, let me find out where it is t statistic and this is p value. So number one, I will check what is the pre-mean. Pre-mean is 43. Second, what is the post-mean? Post-mean is 60. So life quality improves. What is the t statistic? T statistic is minus 9.615, which is greater than minus 1.96, and p value is 0.000. So what is the conclusion here? Conclusion is null hypothesis rejected. Null hypothesis rejected, and it means the life quality after is higher than, is better than life quality pre. So in this way we can also run the paired sample t-test. I will take one more example so that it will be clear again, and let me take one more example. While I am opening the data of paired, yeah, we are having the paired sample t-test here. Okay, so in this case we are having the data of the training score pre and post. So we are having the data of 30 employees, and this is the performance level before the training program, and this is the performance after joining the training program. So it is again a pair statement: pre-training program, post-training program. Let's go to the command. Compare means paired sample t-test. Same command. Make a pair. Send here and just do nothing. Click OK. Now, what is the t statistic here? I think it is same. The pre-training score is 51. Post-training score is 68. So the post-training score is more than pre-training score. Probability value is 9 and significance value is 000. So we can say the post-training program is high. It means the training is highly effective and there is a significant improvement in the training score. Okay. So we are rejecting the null hypothesis. Okay. I hope it is clear. If it is clear, say yes. Otherwise, I will go to the next part, that is called Anova test. Okay. Now, one thing I am going to explain you that why null hypothesis is rejected is significant. Okay. Suppose actually you know that the God makes everybody equal, right? We can we say that the males are better than females, females are better than males? No, because God made everybody equal and independent also. Suppose we want to challenge this, right? So researcher, what researcher is doing? Researcher is actually challenging. Researcher is challenging the null hypothesis. So why we are doing the research? We are doing the research because we are challenging the null hypothesis. So if you challenge the null hypothesis and accept it, it means whatever you do is just a waste, right? So in more than 90% of the cases, the researcher want to reject the hypothesis, right? For example, the nature say that the water and the medicine is same, right? This is the null hypothesis. If you give the water or glucose or the medicine, it will have a same impact. There is no difference between the medicine and the glucose, right? So this is the null hypothesis. Now, because the doctor know that the medicine will definitely improve the patient, so he will challenge the null hypothesis because he want to prove that the medicine is better than the glucose, right? So basically what happens, we challenge the null hypothesis, and in the results, if your null hypothesis rejected, it means you are successful in proving that the null hypothesis is not valid. So we have to reject it. So this is the success of the researcher to challenge the hypothesis and reject it. So because in most of the cases I found that if you are accepting the null hypothesis, it means everybody know that null is there, right? And you challenge it. It means you should prove it that the null hypothesis should be rejected. And if you are starting with the null hypothesis and accepting the null hypothesis, what is your contribution, right? So basically, everybody know that null hypothesis exists, and you also say that null hypothesis exists. It means your contribution is nothing. So in research, we assume the null hypothesis and we want to reject it. We are challenging the null hypothesis. This is the concept of the research. I hope you understand. Okay. Now, Usha Rani madam is asking, is there any cases that we should not reject the null hypothesis? Yeah. So nowadays, there is a concept called gender bias, right? If you want to prove that the male are more intelligent than females, you should not reject the null hypothesis. And if you are examining that whether the shopping of male and female are equal, or male and female, the performance of male and female are equal, if your null hypothesis that performance of male and female are equal, salary of male and female are equal, here you should not reject the null hypothesis. Otherwise, this will be the example of gender biasness, right? If you prove that the performance of female is better, or performance of male is better, or the salary of average income of female is better, or average income of male is better, so that this is coming in the case of gender biasness, right? So that are very complicated issues. So we should be very careful that which null hypothesis should not be rejected and which null hypothesis should be rejected. Okay, so I hope now you have more clarity where to reject the null hypothesis and where to accept the null hypothesis. Okay. Now I am moving to the third case, the fourth case, the one-way ANOVA. So let me explain the theory first, and then I will go to the Spss file. Okay. So I am going to explain one-way ANOVA. Now, what is the properties of one-way ANOVA? Number one, number of groups should be more than 2. Second, the null hypothesis is that the all group means are equal. All group means are equal. So this is the null hypothesis. Teesra, the third, the assumption. The important assumption about here is homogeneity of variance. Homogeneity of variance. Homogeneity of variance, the same thing which we tested in the independent sample t-test. Fourth, what we check? We check F statistic, which should be greater than square of 1.96, and p value should be less than 0.05. So these two conditions are required to reject null hypothesis. After rejecting the null hypothesis, next thing which you can see is called post hoc test. Right? Post hoc test is simply known as group comparison. Group comparison. And after this, we conclude. So this is the simple procedure of one-way ANOVA. If you see all the conditions, that one-way ANOVA is applicable when number of groups should be more than 2, and the mean of all the groups are assumed to be equal. And here we are testing the null hypothesis that homogeneity of variance are the same. Homogeneity of variance means variance of all the groups are same. This is the assumption of the ANOVA. And what conditions you require to reject the null hypothesis? That F should be greater than approximately 4, because 1.96 is approximately 2. So square of the F statistic, square of the 1.96 is coming to be around 4. So if F statistic is more than 4, it means you can reject the null hypothesis. And p value should be less than 0.05 here. And then we will see the post hoc test. I will explain this post hoc test also and conclude. Now I'm showing you the example, and I will explain what is the meaning of all these things. So let me save it. So I'm showing you the practical example, how to do a one-way ANOVA in SPSS, and will explain the results therein. Now we are moving to the ANOVA file. So there are many files. Let me show you the pollution. Okay, first file is pollution. Okay, now here we are having 2 variables. One variable is area and second variable is pollution. So area should come first, pollution should come after. Now we are having 3 cities here. Let me check it. So we are having Delhi, Gurgaon and Ghaziabad. So there are 3 cities. There are 3 cities, Delhi, Gurgaon and Ghaziabad. And we want to check whether the average pollution in all the cities are same or not. So this is the pollution level and this is the area. So let me write here in level the pollution level. This is, and here we are comparing with the 3 cities. Okay. So this is the data. This is the pollution level. Okay. So data view. area and pollution level. How to apply the test? Go to analyze, compare means, and the last option is one-way ANOVA. So if you click on one-way ANOVA, the city, because city is a group category, comes here. Pollution level is a scale variable, comes here. So you have to find out what is the pollution scale variable which comes in the dependent list, and the groups should come in the factor. After that, go to the post op, and we only apply techie test here because techie test is the best of the post op test. And go to the options. We want to see the descriptive files, homogeneity of variance test, and means plot. So 3 options we should select, and only these 2 commands are required. I repeat, after defining the variables, I clicked on the post-op test and click on the to key. You can see here, and continue. In options, you click on the descriptives and homogeneity of variance test and the means plot, and you can click on the continue. Now click OK. So we are getting the result here, and let me explain you each and every result. Okay, let me close it first because previous results are also coming. Again, go to analyze, compare means, one-way ANOVA, pollution level comes here, cities, in post-hoc Turkey, and in options, descriptive, homogeneity, and means plot. So we give all the commands and click OK. Now let me explain you the result of Anova test. So first thing we have to find out that what is the mean of different groups. One mean of Delhi. Delhi is 180 approximately, and Gargaon is 219, and Ghaziabad is 225. So they seems to be unequal. Okay. Now case number 2, step number 2, we have to find out the assumption. This is the assumption, test of homogeneity of variance. So let me check what is the value of assumption here. For assumption, you have to check only the all basic mean. So here the problem is that assumption is rejected. Assumption is rejected. So ideally we should not apply Anova test here because assumption is rejected. But I am showing you the results. Assumptions is rejected, but there is a problem. This p-value should be greater than, this p-value should be greater than 0.05. Then we can say assumption is fulfilled, otherwise not. After that, let's see the value of Anova. Now the next table which we have to check is F statistic and p-value. F statistic is greater than 4 and p-value is less than 0.05. So it means null hypothesis rejected. Null hypothesis rejected. It means different level of pollutions in different cities, or average pollution is not equal. Average pollution level is not equal. So we are concluding that average pollution of the different cities are not equal. Now the problem is that which cities have the different pollutions and which cities have the equal pollution. So this is the answer we have to find out. Now, how to find out? We have to go to the post-hoc test. So we will have this result of the post-hoc test. You can see this table, which is very important table here. And in most of the thesis program, you have to report this homogeneous subset. So what the software is saying? Software is saying that the average of Gurgaon and Ghaziabad are equal because it is coming together. And this is different. So what we can, the conclusion we can write, the average population of Ghaziabad is equal to average population of the Gurgaon, and the average population of both Ghaziabad and Gurgaon is greater than the average pollution of Delhi, right? So the average pollution of Ghaziabad and Gurgaon are equal because they are coming in the same subset, and both have significantly higher level of pollution as compared to Delhi, right? So this is the conclusion you can have, and I am showing you one more results to make you clear about the Anova test. Okay, so let's open some other file so that we can discuss on another data set. Anova. Okay, in this case, we are having 3 programs, and this is the performance level of these 3 programs. So the performance of the 3 programs, you can understand that there are 3 departments in a company, A, B, C. We just call it A department, B department, and C department. And in each department, there are some employees. Like there are 10 employees here in first department number 1, and there are 10 employees in department number 2. Yeah. So in each department, we are having the 10 employees, and we want to know that which department is better performing. So we have to compare the performance, average performance of the employees in 3 departments. Okay, let's go to the data. Analyze, compare means, and pair. One way Anova we want to apply. So this is the command, and we can apply Anova. Why? Because there are 3 groups here. If the number of groups we are having 2, we cannot apply Anova. We can apply t-test. Anova is applicable when you are having the number of groups more than 2, or 3 or more than 3. So program is my factor, and performance is my dependent list, and I want to compare the performance of the 3 programs. Same command we will give here to key test, and in options I should click on descriptive, homogeneity, and means plot. And after giving all the commands, just click OK. Now see the result. The average performance of department A is 15.6 here. The average performance of the department number B is 26, the highest, and C is found to be 22. So it seems that the average performance of department B is the highest, and followed by C, followed by A. Now the question is that, can we say the performance are significantly different? Can we say the performances are significantly different? For that, we have to check first the F test. But before F test, find out the assumption. In this case, the assumptions is fulfilled because the probability value is greater than 0.05. Here, probability value of test of homogeneity of variance is more than 0.05. So we can say the null hypothesis is accepted here. The null hypothesis is accepted. It means the variance of all the groups are equal, and we can apply a one-way Anova test confidently. This is just an assumption. It is not giving you any conclusion, just one assumption whether you can apply one way ANOVA or not. After that, we apply the ANOVA test, and in this case, the null hypothesis is actually the performance of group A is equal to performance of group B is equal to the performance of group C, and assumption is fulfilled, so we don't have any problem in assumptions. Assumption means the variance of A is equal to the variance of B is equal to the variance of C, and we examine the hypothesis by F test, which is greater than 4 and probability value is less than 0.05. You can see F value, P value. So my null hypothesis rejected. So this was my null hypothesis and it was rejected. So I have to find out where the difference exists. Where the difference exists. So let me go to the multiple table. So this homogeneous subset is very important table because it is giving you the conclusion. So what this table is showing, so conclusion is that the group number C and B are same and they are different from the group number A. So I can say the performance of B is similar to the performance of C group, but the performance of B is greater than performance of A, and the performance of C is also greater than the performance of A. So these are this is the conclusion we can draw from the one-way ANOVA test here, right? So this table is very important in one-way ANOVA because this table will tell you where the mean is highest and where the mean is lowest. Okay. Last, I'm taking one more example because it is a complicated test, and I know that the people are very afraid of the ANOVA, that they think that ANOVA is a very difficult test and it is very difficult to learn, but you see that if we know the concept, how easy it is to apply the one-way ANOVA. Now let me close this file and I'm going to open a new file. Just explain one more example. So some basic questions I'm asking to you. When we can apply one-way ANOVA? We can apply one-way ANOVA when there is a number of groups, 3 or more than 3. So let me open one more file and discuss the ANOVA with you. Okay. ANOVA ये कर लेते हैं. Okay. In this case, we are having the income as a variable, and we are having the area. So let's forget all variables. So we are having 3 areas: east, south, and north. So there are 3 areas: east, south, and north, and we want to check whether the average salary of the employees in east, south, and north are same or not. So let's move to the analyze and compare means, then go to the one-way ANOVA. Area is my factor, income is my dependent list, and then we can go to the post-hoc test, that is the key. Continue, and we can go to the descriptive, homogeneity, means plot, and after doing this, just click OK. Now I can see the results here. The average salary of the east people are 45,000, south is 24,000, and north is 23,350. So can we say they are equal? Okay. first of all, check the null hypothesis. So null hypothesis saying that we have to check the based on mean only. So 25.3, it means null hypothesis assumption is fulfilled. If assumption is fulfilled, we can go to the F test. So you know that we have to compare F test with 4. If F value is more than 4, it means null hypothesis can be rejected. Otherwise, we can see the F probability value also. The probability value is also found to be less than 0.05. It means null hypothesis can also be rejected. And what is the result? The result is coming from the subset, homogeneous subset. Here we can conclude that the average salary of north and south are equal, but the average salary of east is significantly higher than the average salary of north and south. So here you can see that the average salary of north and south is lower than, because it is coming in the first subset, so it is lower as compared to the average salary of the south. And we also have this graph which indicate that the average salary of north, the average salary of south is same, and it is significantly lower than the east salary. Okay, now I am telling you some more advanced issues in the topics which you can learn further. This test is basically this test is known as one-way Anova. In one-way Anova, we have one scale variable y and one group variable that is called, let's say, group. Like in the recent example, we are having one grouping variable that is called area. Sometimes we have one variable and two groups, group 1 and group 2. Group 1 may be on the basis of age, and group 2 may be basis of on the experience. So when you have one dependent variable and two groups, this case is known as two-way Anova. Similarly, when you have one dependent variable, two groups, and one independent variable, so this is called ANCOVA. ANCOVA. Similarly, when you are having multi-dependent variables, y1, 1, 2, 1, 3, and independent variables, right, and group 1 and group 2, so this is called MANOVA. So we are having the different cases of ANOVA. Here one-way ANOVA is very popular, two-way ANOVA is very popular. ANCOVA and MANOVA or MANCOVA, we normally do not apply because they are complicated, and some theoretical background is necessary to apply these tests. Okay, so I hope I have covered all the 4 tests which we decided to cover today. That is one sample test, independent sample test, and the ANOVA test. Now 5 minutes are left, and I just want to know if you have any query, please ask. Yeah, so now you can ask your query so that I will solve it if you have any query in your mind. Basically, the t-test and ANOVA test are very common tests applicable in the thesis and the projects, and you can write papers on the basis of t-test and ANOVA test if they are required. So whenever you want to compare the mean, whether of 2 groups or more than 2 groups, you know that t-tests are ANOVA applicable, and these tests are very important tests. So if any query is there, please ask.
I think there is no query. So thank you, sir. You have covered lots of things today related to hypothesis, like t-test, independent t-test, one sample t-test, independent sample t-test, paired sample t-test, one-way Anova, post-hoc analysis. You have covered all the things related to hypothesis. It will definitely help us to implement in our research work. Thank you, sir. Uh, there is one question from Udit Bora, I think.
Actually, I am expecting some questions, so maybe
There is one
like
question, sir.
yeah,
Yes, sir.
Udita is asking one thing. In case of independent sample t-test, if variance is not equal, then what to do? Actually, it is not in only in case of independent sample test. It is also in case of Anova test. When the variance of the samples is not equal, then we are having another category of test which we call non-parametric test. So the t-test and Anova test are basically the parametric test, and these tests requires large sample size and the normality of the distribution and the homogeneity of variance. Homogeneity of variance is important, and it is examined in all the t-test and the Anova test. So in case if these assumptions are not fulfilled, then you can move to the non-parametric test. There are the non-parametric test substitutes of uh, the t-test and Anova. Like we are having Kruskal-Wallis test, we are having Mann-Whitney test. So we also covered these tests in one session, and the answer is very simple. If your assumptions are not fulfilled, then you have to move to the non-parametric test. Okay. Deepika is asking that what is the role of F value in independent sample t-test? Basically, the F value is examining whether the two groups are having equal variance or not. If they are having equal variances, then we can go for the t-test. Otherwise, we have to go for some non-parametric test. And Surabhi Datta is asking, if any one wallet exists, then can we run one Anova? No, actually, if assumptions are not fulfilled, you have to go to the non-parametric test. So we are having some non-parametric test substitutes of Anova, like we have Friedman Anova, we are having Kruskal-Wallis test. So this is the issue actually. The assumption needs to be fulfilled in the statistics, and most of the parametric tests requires normality of the assumptions, normality of the variables, and the homogeneity of variance. So these are the conditions that okay. Then Zumi is asking why we are comparing T statistic with 1.96. Usually we do with Z test only. Okay, actually in statistics we assume that the normality is there, because you know that in parametric test we assume that the normality exists, and the t value is also compared with the help with the 1.96, so there is no other value of t test, so it is exactly same as the Z test. Because Z test is only found in books, it is not found in the practical research. So in practical results, if normality is assumed, then the t test and Z test are exactly same. So that's why in t test also we compare the value with the 1.96. And Smriti is asking, post hoc test is necessary to do through the test is significant. Yes, actually, the F test in one way ANOVA will only tell you that whether to accept the hypothesis or reject the hypothesis, right? But the intergroup comparison is not possible in one way ANOVA only. If you want to see that which group is having highest mean, then other mean, the other group, then you have to go for post hoc test. The post hoc test will exactly tell you that which groups are different and which groups are not different. So ANOVA without post hoc test is incomplete. You cannot apply ANOVA without post hoc test. So post hoc tests are very important test if you are going to run the ANOVA test. So I think
Yes, sir.
no other queries coming, and
So thank you, sir, once again. You have covered all the things, I think, related to hypothesis testing. So today's session was very productive and impactful. Hope tomorrow we'll get more productive sessions,
sure.
sir. Okay, sir. Thank you, sir.
Thank you.
I want an announcement to the participants. Kindly fill up their attendance sheet. Thank you.
Thank you.
Thank you, sir.
Thank you. Okay.